before you watch this video, you should go watch the YouTube video that is the intro video to scientific notation. And after you have watched that video, on the very top of your paper, of your notes, I would like you to write 2 examples of scientific notation that you saw in the video. So if you need to go back and look through it again, that would be great. I just want to make sure that you watched that video and that you're listening to what I am saying right now. So I will be looking for those 2 things up on the top of your paper when you submit your notes. All right, let's get into this. Scientific notation. Scientific notation is a compact way to write really large and small numbers. The music video kind of talked about this a little bit, but this first number here, this 2.8, or the first factor, is a number that is in between 1 and 10, so we'll write that with an inequality. It has to be greater than 1 and less than 10, so in between 1 and 10. It might be a decimal, but it cannot be a decimal like 0.5, okay? It has to be a decimal like 1.2, something in between 1 and 10, not less than 1. Okay, that second factor is always going to have a base of 10. And then the power of the exponent tells you how many times to move the decimal point. The sign of the exponent, so whether it's positive or negative, tells us which way to remove it. So which direction to move it. So if it's a positive exponent, you're going to move to the right, think big number. And if it's a negative exponent, you're going to move the decimal place to the left, think small number. Okay, so when I say standard notation, what is standard notation? Standard notation is the way that we normally write numbers. Like $150,000. Okay. If we look at our first example, there are approximately 331 billion people in the United States. We want to write this number in scientific notation. So this number was given to us in standard notation. We want to write it in scientific notation. So what we're going to do is we see this is a really big number, right? So it's a big number. So that means we're going to have a positive exponent on my base. So we know we're going to have something times 10 to a positive exponent. Okay, so what I mean by we're going to move our decimal point is our decimal point right now is right here on the very end. It's a very big number. Okay, so if we want to go back and see, we have to have a number in between 1 and 10. So I'm going to go back how many times? 1, 2, 3, 4, 5, 6, 7. If I stop there, that's only 33.1. Got to go one more. So I went over 8 times. So my first number is going to be 3.31 times 10 to the 8th power. So if we were given this as my number in scientific notation, to go into standard notation, we would just go the opposite way and move my decimal place to the right 8 times. 1, 2, 3, 4, etc., etc. Okay, and that would get us to this number of 331 billion. So this is 3.31 times 10 to the 8th people in the United States. Okay, our next example, we have 1 grain of sand that weighs about 0.000604 kilograms. We want to write this number in scientific notation. So we've got a really small number, which means we're going to have a negative exponent. So wherever our decimal point is, we know we're going to have something times 10 to a negative exponent. And I want to make sure we are counting over until we get a number that is in between 1 and 10. And that is when we're going to stop. So I'm going over 1, 2, 3, 4 times. And it would be at 6.04. If I go over 5 times, that's 60.4. We want a number in between 1 and 10. So we went over 4 times, so it's going to be times 10 to the negative 4th power. And then our units was kilograms. Okay. Let's keep changing some standard notation numbers into scientific notation, and then we'll go the opposite way. So I'm going to do 3 of them with you, and the other 2 you're going to do by yourself. So this first one here, I know this is a big number, so you're thinking it's going to have a positive exponent. So something times 10 to a positive number. Let's go ahead. My decimal point is there, so I'm going to count over until I get a number in between 1 and 10. So 1, 2, 3, 4 times. So my exponent's 4. My number is 4.5. I don't need to write all of those zeros. That is the whole point of scientific notation. It allows us to get rid of those zeros. Okay, let's look at number 4. Number 4 is a really small number. So small number means it's going to be a negative exponent. So I know it's times 10 to the negative power of something. And I'm going over how many times? 1, 2, 3, 4, 5 to get a number in between 1 and 10. So 3.78 times 10 to the negative 5th power. And last one I'll do is number 6. Number 6 is a big number. There is no decimal place. So it's going to have a positive exponent. And we're going to start at the very end and count over to get a number in between 1 and 10. So 1, 2, 3. If I stop here, I'm only at 670. Need to keep going. 4 would put me at 67. 5 puts me at 6.7. So I've got 6.7. And you do need to include that 0.4 because that 0.4 is really including that 70,400. It's including that extra 400. So we do need that. And then times 10 to the positive 5th power because we went over 1, 2, 3, 4, 5 times. Okay, pause this video quick, try out the other 2, unpause the video, check your answers. All right, so you should have gotten these 2 answers for numbers 3 and 5. Double check those. And then let's move on to the other side here. We're going to talk about moving from from scientific notation into standard notation. So we're just going backwards now. So we got to look at some things with my exponents here. If I look at my exponent of negative 6 on that base of 10, that tells me we're going to have a really small number. So my decimal point is here. If I want a really small number, I need to move to the left. So I'm going to go left 6 times. 1, 2, 3, 4, 5, 6. That is where my decimal place is going to be now. And I'm going to fill all those empty spots with zeros. So my final answer is 0.0000946. So there's 5 zeros there. Okay, looking at number 4, I've got a positive exponent here, which means we're going to have a big number. Okay, so if I write 4 here, my decimal point is technically there. Big number, would we go to the right or the left? Think about it. We're going to the right. So I'm going to the right 5 times. 1, 2, 3, 4, 5. That is now where my decimal point is. And I'm going to fill all these things in with zeros here. So I've got 4 and then 5 zeros. And now the one thing that we need to add in here is some commas to make it easier to say what this number is. So starting at the end, count back 3 and put commas every single time. And so 400,000 is my answer for this one. All right, I'm going to do number 6 with you, and you are going to try out number 5 on your own. My exponent here on number 6 is negative 8. which means this is going to be a small number. So I'm going to rewrite my number down here. So I've got more space. And I'm counting back 8 times. So my decimal place is here. I'm counting back to the left 8 times because it's a small number. 1, 2, 3, 4, 5, 6, 7, 8. Filling all of those in with zeros. So 7 zeros if I counted correctly. And then that whole thing, 3, 2, 4, 5, 6 has to go in there. Okay, pause this video, try number 5, and check your answer. Okay, so now that you know how to change from scientific notation to standard notation, we're going to talk about multiplying and dividing with numbers that are in scientific notation. It's basically using our exponent properties combined, so that way it's easier to multiply big numbers and small numbers. So we got to quick remember 2 important exponent properties. The first one being the product rule. The product rule is anything to a power times that same base to that power. You are going to add those 2 exponents together. And then our quotient rule, if we divide things with the same base, we're going to subtract the exponents. So that's going to come in handy here with our multiplying and dividing in scientific notation. And then there is an acronym that I like to use to help you remember where you need to move the decimal place and what you need to do with the exponent if you have to do anything at the end. So the acronym is called LARS, and that stands for left add, right subtract. So when you are moving your decimal place to the left, you are going to add 1 or however many you are moving your decimal place to your exponent. If you move to the right with your decimal place, you are going to subtract that number. Okay, so let's go ahead and look at a few examples. First one, I've got 3 times 10 to the 5th power and 2 times 10 to the negative 12th power. So we're going to split this up and we're going to look at just that base in front. So the 3 and the 2, I'm going to multiply those together outside. So I've got 3 times 2 here, and 3 times 2 we know is going to give us 6. Okay, now let's look at my 10 to the power of 5, 10 to the power of negative 12. And we're going to multiply those together. Because remember, multiplication is commutative, so you can move the order, and that's okay. So now that I have the same base here, my base is the same, I'm going to add those exponents together. So I'm adding 5 plus negative 12 together to give me 10 to the negative 7th power. So this is my final answer in scientific notation, 6 times 10 to the negative 7th power. Or if we were writing this in standard form, we would have my 6 here, and then I would move the decimal place to the left 7 times, and then add zeros in front of that. Okay, so this would be a really small number. Okay, let's look at the next one. Got 1.2 times 10 to the negative 12th, and 9 times 10 to the negative 8. So we're going to multiply our numbers outside first with each other. So 1.2 times 9 would give me 10.8. And then we're going to go ahead and multiply our bases together. So I've got 10 to the negative 12th power times 10 to the negative 8 power. And we are going to add those exponents together. So negative 12 plus negative 8. I will just plug that in your calculator. Okay, it'll make less mistakes that way. So then I've got times 10 to the negative 20th power. Now, one thing about scientific notation is that this number has to be in between 1 and 10, right? And since it is not, we need to change that. So that's where that acronym comes into place. So I want to move that decimal place to the left one so that it is 1.08 and that it is in scientific notation. And if I'm moving it to the left one, I'm going to add 1 to my exponent. So I've got 1.08 times 10 to the negative 20 plus 1, since I moved it to the left 1 time. So this would actually be final answer 1.08 times 10 to the negative 19th power. So really, really small number there. All right, and we're just going to look at this example right here. If you want to check your answer on this third box, you should end up with 4 times 10 to the 6th power. But I want to talk about this one right here. For division, we're going to do the same idea. We're going to take these numbers right here and divide them. So when I plug that in my calculator, 1.21 divided by 4.81, we end up with 0.25. Okay, and then I'm going to do the same thing with my 10 to the power of exponents. And then I've got 10 to the 7th power divided by 10 to the 5th power. And when I divide, I'm going to subtract my exponents. So I have times 10 to the negative 2nd power. Oh, sorry, I mean positive 2. Positive 2. And then this number right here is not in between 1 and 10, right? So I need to make it in between 1 and 10, which means I need to move. So that way I have 2.5 times 10 to not the second, but with my acronym, when I move to the right, I am going to subtract. So I'm going to subtract the number of places I move, so minus 1. So this would become final answer of 2.5 times 10 to the first power. Okay, so just take it one thing at a time, divide your numbers or multiply your numbers, and then either subtract or add your exponents. And then the last thing is on the delta math, it's going to talk about the words product and quotient. So when it says product, that means you are multiplying those numbers together. When it says quotient, you will be dividing the numbers. So just be careful when you're looking at the delta math and looking at what it's asking you. Okay, if you have any questions, please feel free to ask.